Hey judges, thanks for tuning in. Appreciate your time. My name's Anish. I'll be going over my submission for Earthx hacks, named Zeus, right? And the whole motto for Zeus is making resource conservation fun, as you can see here. All right, so I'll go over inspiration, what the product does, and some technical details at the end. It should be pretty short, about 10 minutes. All right, so let's first start out with what the product does and why I came to the solution I did. One thing I noticed when I was watching the videos and the goals for this hackathon is a lack of economic incentives to push people towards being environmentally friendly. Right, there are a lot of incentives for people to be sloppy, and there aren't enough. It's called a social externality economically, but the issue is that there's not enough incentives against free usage of electricity and overconsumption of electricity, along with other goods like water and gas and so on. What I noticed is that we need to find a way to align incentives from a governmental point of view all the way down to an individual point of view, so that people now want to spend less and they want to consume less and help the environment while they're doing it, and also be economically incentivized to do it. Right, so let's talk about how Zeus does this. What we do. So I want you to focus on the first diagram here, right? What this shows is a very typical utility provider and consumer flowchart. The utility provider provides utilities like gas, electricity, and water to the consumers. And the consumers in return give money, and the utility provider makes money off the spread. The issue with this is there's an incentive de-alignment between environmental friendliness and, in this case, utility-consumer relationships. In this case, in this flowchart, utility providers make money by selling more, by making their consumers either consume more or by reducing their bottom line. But in the first case of increased consumption, that is against environmental goals. We want people to spend less, to use less electricity, water, and other non-renewable goods, because those have impacts on the environment which we want to limit. Right? That's the whole idea, limiting environmental impact. So let's instead look at diagram 2. Right? The issue with the top one is because we have stakeholders, like shareholders, we have to make a profit. But in the second one, can we find a way to both make a profit and reduce consumption? And the answer is yes. That is what Zeus does. So in this case, let's actually go over an example. This is abstract. Let's go over a concrete example, very simple to understand. We have 3 consumers. Let's say in a month they usually spend $2,000 worth of electricity. The government can come in and basically say, hey, utility provider, you usually make $2,000 a month. I will pay you $2,100 a month to keep providing electricity, and I want you to push down consumption as much as possible. Right? So from a government point of view, their goal is from tax money to spend this on limiting consumption, right? Because it's an environmental goal. As long as society decides that's a good goal, which we have, that is a good spend of money. From a utility provider point of view, they get paid from the government and they don't lose money off consumption. They actually make money by reducing consumption. Let's explain why. The government pays them $2,100. Let's say consumers now only end up spending $1,800 due to efforts by the utility provider. What's the spread? $300. The utility provider now gets to keep that entirely. That's additional money in their bank. Before, they were only making money off the spread of their own, off of selling more, but now they make less variance because they have a less varied supply and demand off the government. It's not privy to as many fluctuations. They both reduce variance and increase profits. So we found alignment between the government and utility provider. Utility provider now has an incentive to reduce consumption. Let's now talk about what Zeus does to help consumers reduce consumption, right? And we'll view this in the app itself. So the app has a Google-based login. I was already logged in, I had to log back out. But login, Google, typical Google OAuth, log into my account. As you can see here, we'll see the screen with a profile and standings, which will be loading. And you'll see one really important thing I want you to focus on is the prize pool here, right? But let's go over what is on this page. So in the top right, we see 48th percentile. What is 48th percentile? Well, it is your standing in the amount of utilities you're using, right? So let's say there's 100 people and I use the 48th most amount of electricity. I would be the 48th percentile. That's what this is saying. But the goal here is to basically create a stack ranking out of every single consumer in a given area and rank them based on their total consumption. High consumption is bad, we should disincentivize that. Low consumption is good, we should incentivize that. Right? So what it says here is you're doing your part, you're doing all right. You don't qualify the benefits I'll talk about in just a second, but you're not being actively environmentally bad. And says you're so close, try turning off some lights around the house. Right? So then we see the more important part of this, which is the standings and the prize pool. So let's look at this map. Right? On this map, you'll see a heat map. Yellow is low, red is high. This isn't actual data, but it's close. I mean, in the sense that the data doesn't really matter. It's a mocking system, but the high level stays the exact same. Let's look at this red spot here, right? This says electricity consumption is 16.92, ranked 75 out of 1,000. Then I have a yellow over here. That'll click. That's not really the point. The point is that you can see how much you're using and how much neighbors are using. But the idea here is to get a heat map of a given area. So for example, let's say I want to view my neighborhood and how much electricity we're using locally. Excuse me, a little stuff here. We can zoom out, zoom into the utility area, and you'll see here a bunch of different points representing heat maps, right? Representing usage of electricity. And what this shows you is how much your neighbors are doing for you. One really important incentive is actually comparison of you to people around you. Humans are interesting that way, in the way that objective facts don't really shake us, but saying in comparison to someone else that's what they're doing really changes our mindset on how we should be doing things. So we can say that 40% of people are using less than this much electricity. That really pushes people quite a bit to also hit that same goal. But from an economic point of view, what this also does is this contributes to your stake in the prize pool, in the sense that this prize pool is something offered by the utility provider to individuals, to households, to push them to consume less. Right? If you're in the least 20% of consumers, you make money off this prize pool. You're incentivized to spend less electricity and fit into the top 20%, and then make money on this $500 prize pool because you get some of that. Right? This is really a portion of what the spread is between what the utility provider expects and what the government is paying them, because they want to push people's consumption down as low as possible. These incentives offered here push down households' consumption. Right? So now we have a goal alignment. Bear with me here. We have a goal alignment between the government, the utility provider, and the individual. And why? Government, because they're deemed it's a social good to reduce the amount of pollution and consumption, they're offering money to utility providers to push them to spend less. Utility providers make money now off of spending less, having less variance in how much they make, and furthermore, that increased spread. And furthermore, individuals now make money off of this prize pool. So we have a total alignment of incentives, right? Everyone now wants to be environmentally friendly, which is a radical mindset change from what it was before, where you had to spend money out of your own pocket to be environmentally friendly. This is different. So now that we see that this idea is very reasonable as well, in the sense that incentives align, let's talk about technical implementation and how this works. Right? This is a pretty simple application. We use AWS EC2 for the deployment. Furthermore, we have a React Redux front end, a Node.js backend with TypeScript, and then we use DynamoDB, which is an AWS database for user data storage. Right? That's where all these little dots come from, and this map is Google Maps, obviously. And some really nice CSS animations, if I say so myself. And I used essentially Nginx to optimize some of the data pools and some of the compression from the back end to front end. And if you want to view the site, you can go ahead and view it, log in with your own information on https zeuselectric.org. It's a domain I own that I just got for the hackathon. But essentially, we've seen how this product works. We've seen the idea. We've seen the why. I don't think the tech details matter much. It's the why this product exists, right? And that is that it is a radical mindset difference from what we had before, where you had to go out of your way to spend money to be basically tech friendly, green friendly. Now, the system itself is green friendly, right? Which is immensely valuable because humans are resistant to change. Thank you for your time. I appreciate the judging. Stay safe.